Today we're going to start our section on parametric equations. And so we're going to start pretty simple, and then we're going to move on to real world problems as we move forward on these lessons. It says a parametric equation is a set of two separate equations for the motion of an object, one for the x component and one for the y component. Both of these equations have the variable of time, t. So when we look at these equations, it's very similar to the equations we've looked at previously. The difference is that we've got this parameter in there of t, making it a parametric equation. In an equation like a linear equation, the x can represent the horizontal distance and the y can represent the vertical distance. But we don't know when it's at that point. We just know how far it went and how high it went. With a parametric, by adding the parameter of t, now we know at what time it went that far horizontally and that far vertically. So on our first graph here, it says to graph these between 0 and 4. T is between 0 and 4. So our time is going to be 0, 1, 2, 3, and 4. What we do to find our x value is that we use our parametric equation here of 3 minus 2t to find the x values. Then to find the y values, we use that -4 plus t. And you're just building a table of values like you've built before in the past. You're going to plug in that 0 for the t here. So that would be 3 minus 2 times 0, which is 3. 3 minus 2 times 1, which is 1. 3 minus 2 times 2, which is -1. 3 minus 2 times 3 is -3. And 3 minus 2 times 4 gives us a -5. So these are going to be the x values for our parametric equation. Now we would take these t values and plug them in for the t to find our vertical values or our y's. And so we get -4 plus 0, which is -4, -4 plus 1, which is -3. And then we continue to plug that in and we get -2, -1, and 0. With a parametric equation, that time component is important. So we are going to start graphing these, and we start graphing them in order. For time 0, it's 3 and -4. So that's the first point I'm going to plot here. The next point would be 1 and -3. The next one is -1 and -2. -3, -1, and -5, 0. I'm going to go ahead and start where my first point is, and I'm going to connect my points now. And then we put a little arrow here to show its direction. So this is my first endpoint, this is my last one here, and it is moving in this direction. That means that when t was equal to 0, we were at 3 horizontally and -4 vertically. When t was equal to 1, it gave us this point. When t was equal to 2, t equals 3, and then t is equal to 4. So that's what that means there. When you draw this, you do connect the points and put our arrows here showing its direction. All right, we're going to expand on that a little bit here with another example. And it tells us the difference between the parametric equation and the Cartesian equation for this line is that the Cartesian form has no indication of time or direction of motion. The parametric equation tells us exactly where each point is at a given time and what direction it is moving. Now, actually, before we move to that one, as we were summarizing that part here, I do want to show you how to do that on the calculator. So on our calculator here, let me put this down. We go to mode, and we've used that before to change from radian to degree and degree to radian. But this time we're going to go down to where it says function, and we're going to move over to the right where it says parametric. If you're using the school calculator, it just says para, P-A-R, or P-A-R-A. That's the same thing. It's that parametric equation. That's what we want to switch it to. Now when we go to our y equals, it gives me the opportunity to put in the x and the y part in there. So for x, I'm going to put 3 minus 2. And when I hit the key that we've always used for x here, it's going to automatically put a t since we've changed it to parametric mode. For the y, I'm going to put -4 plus t. And so now I've got both of my equations. In order to see this on the window, and if you want to see exactly the way it is here, remember you can always go to your window and change what it looks like. So in here, it looks like we were going 0 to 2 pi on the t on whatever I did last. But in this case, the t is going from 0 to 4. So I want to make sure that that's what I put there for my t values. And they are going every 1. So the t step is by what you're changing this by, and it is changing by 1. So I'm going to put my t step as 1. If I want to do the same window that's on my paper, I would go from -5 to 5 and -5 to 5. That's going to give me the same exact window that I have here because it's going from -5 to 5 and -5 to 5. I hit graph and there is my line. Notice that it looks exactly like it does on my paper. The calculator doesn't show the arrows, but you do have to show those on there to get points on showing the direction. So your calculator helps out with these parametrics as well. If you hit second graph, that would take you to the table, and then you can find the table values that we were doing here. So we actually plugged the points in just to get them, but notice that they're exactly the same points as what we plugged in to get. So the calculator can also help you filling out these tables a little bit quicker than just plugging the points in. All right, now that we just did that, we'll actually use that for this second one so that we can fill out the table a little bit faster. It's telling us to graph the parametric equations. So I'm going to go to my y equals again, and this time I'm going to put in my equations here so we can use the table. So for x, I'm going to put my first one, which is -2 plus t. And then the y value that goes with that is 5 minus 2t. This does have a second set of parametrics right here that we're going to look at. So I'm going to put that in right now as well. I get 1 minus t as my x, and my y is 1 plus t. We are using the same time from 0 to 4. So let's get ready to fill out this table here. So t is going to be my first one. X is equal to -2 plus t. Y is equal to 5 minus 2t. X is equal to 1 minus t. And y, not x. Y is equal to 1 plus t. Now I'm going to go ahead and put in my t values here, 0, 1, 2, 3, and 4. And I'm going to go ahead and use the table, the calculators to fill these out just so we can move through this a little bit quicker. We hit second graph, and that takes us to our table. So I can easily use the table from the calculator to help me fill out this table. You could plug in that 0 there, -2 plus 0 is -2. So it is easy to plug those in and write the table as well if you didn't have a calculator. So I filled out my first column. I'm going to go ahead and fill out my second column. That would be 5, 3, 1, -1, and -3. My next column is going to be 1, 0, -1, -2, and -3. And then my last one is 1, 2, 3, 4, and 5. Now we're ready to graph these. So again, I start when time is 0. So my first location is -2, 5. My next point is at -1, 3, 0, 1, 1, -1, and 2, -3. There's my first line. I'm going to go ahead and draw the other one with a different color just so you can see that one. I start again where t is equal to 0. So I'm going to start at 1, 1. And this one is headed in the other direction. So 0, 2, -1, 3, -2, 4, and -3, 5. So we started down here and we moved in this direction. So my arrows would point this way. And so there is my second graph. So it asks us down here, do their lines of travel intersect? And yes, they do. Our lines intersect right here. So yes, Now, the second question says, do the two objects collide? In that case, there's more thought that needs to go into it. It's not just that simple intersection there, because the answer for this one is no, they do not collide. Yes, they intersect right here. So they were at the same location at some point, but they weren't at the same location at the same time. If you think about all the airplanes at the airport, they're all at the same location, but they didn't crash because they weren't at the same location at the same time. So just because they went down the same runway doesn't mean that they collide. So I do want to make a note here that they must be at the same place at the same time. And that's not happening here. In this case, the first one at t equals 1 is at -1, 3. And the second one at t equals 2 is at -1, 3. So that's why they didn't collide, is because one was there at 1 second and the other one was there at 2 seconds. All right, we're going to take a look at another one here. Again, I'll use my calculator to plug these in, and we're going from 0 to 4 again. So I'm going to go ahead and put my t values there. For the first x, that's 3 plus 2t and -2 plus t. For the second one, we've got -1 plus 4t and 6 minus 3t. And so I'm going to go ahead and use my calculator and just fill those out so that we have those values to graph and talk about. If you want to put it in the calculator and check, you want to practice making sure that you can put that in the calculator. You can also practice plugging those in. Sorry about that, a piece of lead was under there. All right, now we're ready to graph our two lines here. I always start where t is 0, and so that is at 3, -2. And then I go to 5, -1, 7, 0, 9, 1, and 11, 2. And so this one is moving in this direction, so I'm going to have my arrows pointing there. And then I'm going to start with my second one, and it starts at -1, 6, 3, 3, 7, 0, 11, -3, and 15, -6 is off the paper, so I can't really graph that one, or off the graph. This one is headed in this direction here. So my arrows go there. I will actually keep going since that other one is off the graph there. All right, so this one says, do they intersect? Yes, the two lines intersect. And then it says, do the two objects collide? And as we look at these, those do collide, because if we look at 2 seconds here, they are both at 7, 0 at the 2 second mark. So this one is yes. At t equals 2, they are both at 7, 0. So this one does collide because they're at the same place at the same time. All right, the next problem that you have there, we're just going to fill out some information on some questions that look similar to quiz and test questions, just for you to get comfortable doing them. On this particular one, it's not very different from the other ones that we've got there. It's just putting our t values in the table instead of giving us our domain restrictions like -2 to 2. So instead of doing it with the bracket notation, they put it in the table for you. There's no difference in how we work it. You would just fill out your table. And then you would just graph the points. And so here we start with -2, -7. -1, -4. 0, -1, 1, 2, and 2, 5. And we did start from down here and move in this direction. So I want to make sure that I point out what direction we're going. All right. The last thing I want to point out is we've dealt with several different functions. So these parametrics can actually be done with several different functions. They don't just have to be linear. For example, we have a quadratic here. You would still work it exactly the same way. We're going to use our t values to plug that in and find what our x and our y's are. So you would plug in 0 for the t there, and that would be 0 squared and negative, which is 0. You would plug in 0 for the y, and so 0 times 2 is 0, minus 3 is -3. And that would give you our first point. 1/2, I would plug in there, 1/2 squared is 1/4 times the negative is -1/4. If you use your calculator, it would give you the same exact values. So you can use your calculator as well. It'll give it to you in decimal values. And then you can change them to fractions if you prefer. When graphing these, don't get scared by the fact that it is a decimal or fraction. You're still going to be able to do that. So 0, -3 is right here. This value of -1/4 is between 0 and -1. So anywhere that you go between that 0 and -1 is going to be okay. And then we go to -1, -1. -2.25 would fall between -2 and -3. So I would go anywhere in between there. And there's my point. Then -4, 1. -6.25 is going to be somewhere between that -6 and -7. And then -9, 3. So in this case, instead of getting a line, we got a curve. That was because that squared term, but it worked exactly like we did the other one. Now, there could be some questions that ask you to work backwards and really think through the points. Like example 6 says a curve is defined by the parametric equation x equals cosine of theta and y equals sine of theta. The coordinates of the point with parameter theta equals pi over 2 r. So it's asking you for the point. This is the parameter theta. That's the one that is listed in both of these. So instead of having a t there, we just have the theta. And so it's asking for what point is going to exist at pi over 2. If you want to think about that as a table of values, this would be theta, x, and y. And so it's telling us pi over 2 is the theta that we're looking for. And so we would want the x and y that corresponds with that. So just like we did the tables, we plug that pi over 2 in for that theta. So we get x equals cosine of pi over 2. Now I know you guys all remember your unit circle because we told you how important that was. And so we're looking for the cosine of pi over 2, and pi over 2 is 90 degrees. And at 90 degrees, x is 0. Then I would do y is equal to sine of pi over 2. Again, that's 90 degrees, and our y value is 1 at 90 degrees. So that point would be 0, 1. In example 7, it has you go backwards given this parametric equation. And again, all kinds of different functions we've dealt with this year. We saw some linear, we saw some quadratic, now we saw some trig, and now we're seeing some rationals. So these parametrics can be built of any of those functions that we've dealt with. Given this parametric, when does the point -5 over 2 occur? So this time they gave us the x and y value because that's what the ordered pair is, the x and the y. And it is asking you when. So it wants to know what is t when we have this point. Well, since we know the x and the y, we can plug that in. So I can get -1 is equal to 3 over 1 minus t. If you remember with rationals, to solve this, I would cross multiply. So I get 3 is equal to -1 plus t. I add the 1 and I get t is equal to 4. So when t is 4, that's when we're going to get this ordered pair. Well, you may be thinking we didn't plug this one in, but remember, once we plugged in a t, it gives us an ordered pair. And if these are already grouped together, they should go together. But I'll go ahead and show you that it does come out to be the same value. So it doesn't really matter which one you decide to plug in there. Again, I cross multiply and I get 10 equals -10 plus 5t. I add the 10 to get it to the other side. So we get 20 is equal to 5t. And we divide by 5 and t is 4. So whether you want to plug in that x or that y, you're going to get the same exact value since it is an ordered pair that came from that parameter. So that's our parametrics day 1. Next class, we're going to get a little bit further into the real world problems that would take this and use them.